Adjunct Professor Moran, Macroeconomics 111. We're continuing our discussion of aggregate demand, and we're going to now compare how the multiplier is shown in the aggregate expense model and how it's shown in our new aggregate demand model. The multiplier is the concept that an initial change in spending by any one of the four components of aggregate demand will have a greater impact on GDP. A dollar spent on a good or service may lead, a change in aggregate demand, that is, may lead to a $4 change in output. That's because one person's expense is another person's income. And income is the primary determinant of consumption. Part of that change in income will be consumed and part saved. The part that's spent is income to somebody else, which is then consumed and saved. So that initial change in spending will ripple throughout the economy, producing a larger change in output than the initial change in spending. In our aggregate expense model, the multiplier was shown as a vertical change, as a horizontal change on the GDP axis. So in our last chapter, we had aggregate expenses here, GDP here. Perhaps this was the original aggregate expense line. And maybe this was full employment. Maybe this level of GDP was 100. Maybe this was 200. Let's make that 300 and 400. We need GDP to change by 100. This is the amount we need GDP to change by in order to get us from a recessionary equilibrium to a full employment equilibrium. Let's assume the slope of this line, the marginal propensity to consume, is 0.75. The marginal propensity to save will be 0.25. The spending multiplier is 1 over the marginal propensity to save. 1 over 0.25 is 4. The formula we need to use is aggregate expenditures equals change in GDP equals change in aggregate expenditures times the spending multiplier. We know we want GDP to change by 100, and we know the multiplier is 4. We need to solve algebraically for the change in aggregate expenditures. Dividing both sides by 4, we determine that if we can change aggregate expenditures by 25 from 300 and 300 to 325, that eventually there will be a change in output from 300 to 400. That initial change of 25 in spending will cause a change in total output of 100. GDP and aggregate expenditures are equal. These are equilibriums at 300, 300, and 400, 400. One equilibrium is recessionary, the other equilibrium is full employment. When the government, for example, if the change in aggregate expenditures is government spending, it will take us out of an equilibrium of 300, 300, and it will give us aggregate expenditures of 325, but GDP of 300. Buying will be greater than making. Buying being represented by aggregate expenditures, making being represented by GDP. There will be a decrease. There will be an unplanned decrease in business inventories. That's a good sign for a businessman. He's selling more than he thought. That will lead the businessman to produce more. That means that he'll have to hire more workers. Unemployment will fall. Income rises. Income is the primary determinant of consumption. But a rise in income is not spent dollar for dollar. It's spent 75 cents and saved 25 cents. So this disequilibrium will cause a ride up this aggregate expense line to an equilibrium of 400, 400, where there's no change in unplanned inventories. And so 400, 400, we had a new equilibrium of full employment. But this change is the multiplier. In our new model, the multiplier will be represented. The formulas are all the same. We're starting GDP real. You have to put real here now, not necessarily here, because when there was an increase in output, income went up, prices were assumed to go up. When there was a fall, income went down, but prices was falling. So there was no change in real income. So you don't have to specify. But here, we're specifically allowing the price level to change. So you have to specify that's real output. If this same change happens, and this is our current equilibrium, 300. A change in government spending of 25 will move the aggregate demand curve this way. To 325. The invisible hand takes over. So this is how it's represented on the aggregate expense line. This is how it's shown on the aggregate demand, average supply model. And then the invisible hand takes over and moves us out another 75. Notice this is a change of 25. This is a change of 75 equals 100. The multiplier was 4. Think of this as 4 rounds. This is round 1, the initial change. Then this happens 3 more times. 3 times 25 is 75. The multiplier is 4. 1 for the initial start, 3 for the 3 successive rounds of the invisible hand that takes us the rest of the way. This is the multiplier. This is how it's shown in the average demand, average supply model.